Yes, good afternoon. We're live now on Lasso Radio, and it's 1:30, so it's time for the Tech Talk show with me, Kazeem. And today on the Tech Talk Wednesday, we're going to be talking SQL Server all the way. And I've got Deepthi on the show with me this afternoon. You're welcome on the Tech Talk show this afternoon, Deepthi.
Thank you so much, Kazeem. Thank you so much for having me today.
Yes. Oh, is it morning? Is it afternoon? Is it evening where you are right now?
Actually, I live in United States, Frankfurt, Kentucky area. So it's early in the morning, 7:30 exactly.
Okay, so it's afternoon here in Nigeria. So I think it will be proper for us to start things off with an introduction.
Sure.
So please, yes, so let us learn a little bit about you, Deepthi, and then we can get into the business of the day.
Sure. Hello, everyone. My name is Deepthi Goguri. So I am a database administrator with having several years of experience as a database administrator in serving SQL Server and databases. I'm a Microsoft certified trainer and Microsoft certified solution expert. I did my master's in computer technology here in United States at Eastern Illinois University, and I do blog for dbanuggets.com. That's my website. And if you would like to contact me, I'm very available on Twitter. You can contact me at dbanuggets. That's my user ID. Um, so yeah, I'm like really excited to talk about SQL Server internals and architecture.
Yes, exactly, Deepthi. So since we're talking SQL Server today, so I've decided to, not the physical art though, so I've decided to come in today with my SQL art on. So can you tell us a little bit about what we're going to be learning from you today, Deepthi?
Yeah. So what are we going to discuss today? So we will
Yeah.
start with the basics, very basics, because basic concepts are really important. We'll talk about asset properties, and then we will go through the life cycle of a query, like what happens behind the scenes whenever we submit any query to the SQL Server, like before even seeing the results on our screen, what exactly happens at each component inside SQL Engine. And then if at all we have some time, we can go through the demo of how that happens. But if that is not sufficient, then we can make sure we have an full complete session later at certain point of time.
Okay. Deepthi, here's what I want us to do. I don't want us to assume anything in the process, right? Because we have, students listening to us right now and some other people as well. So it would be nice to assume zero knowledge for everyone. So some
Okay.
of the concept that we're going to be talking about, it will really be nice if we can try to really break things down and assume people really don't know so much about this, right?
Sure.
Yes, but let's start with this, Deepthi. When we say SQL Server internals and architecture, right? Are we
Mhm.
still talking about the same popular Microsoft SQL Server that most of us know, or does this mean something totally different?
No, it's a relational database. It's bound to be the SQL Server, all about SQL Server.
Yeah, okay. All right. When we generally talk databases, a lot of people sometimes like to confuse it for anything that can hold data, right?
Mhm.
So sometimes people just like to assume, oh, file system, a file system can hold data. Microsoft Excel can be used to hold data, right? But there's a really big difference between an RDBMS, right? Like a SQL Server and the likes of those storage systems, like the regular file system, the Excel of this world. So I want to believe that that's one big difference, between an RDBMS and those other flat file system is this acid property, acid test. Is that
Yeah.
correct, Deepthi?
Yes, the asset property. Um,
Okay. So
so
I will
basically,
really need you to help us understand this better. What is acid property?
yeah. So every major relational engine, right? It can be the SQL Server, Oracle, PostgreSQL, Sybase. All these are relational engines, right? So all of these relational engines should basically satisfy the ACID properties of transaction. So what is this ACID? A stands for atomicity. Atomic meaning a single unit of transaction, like a single unit of work. A single transaction can contain one operation or it can contain multiple operations in it. Each and every single operation inside the transaction should either complete successfully or none of them. Like there cannot be an intermediate state. Let's take an example. Like we all have those store procedures, right? Those simple store procedures. Let's assume we have two operations in that store procedure, an insert statement as well as an update statement. Whenever we execute the store procedure, both of those operations should either complete successfully or none of them. Like if there is the update succeed and if the insert fail, then SQL Server should roll back the entire transaction. That's atomicity. C stands for consistency. So consistency meaning the data should always be consistent before starting the transaction and after completing the transaction. Let's take an example. Like I wanted to insert bunch of records into a table, right? Like while I am inserting, if something happens suddenly, like if there is a power outage and we have to restart the SQL Server later, all these uncommitted transactions should be completely rolled back, making the data in the consistent state. That's consistency. I stands for isolation. Isolation meaning, see, like we don't do one transaction at a time, right? If you have a website, many people will be working on the same website at the same time. So no matter how many concurrent transactions are happening at the same time, each and every individual transaction should be independent of each other and should not be interfering with any other transaction. Let's take an example. Like I wanted to while like if I'm doing some insert kind of transaction, while I'm doing that insert, none of the other transactions should even know that I'm doing an insert. That's isolation. And the last part, the durability is all about how durable our data is. Like once the transaction has been successfully completed and all the data has already been made to the database should be permanent. Like there should not be any data loss later down the road if we have to restart the SQL Server or any other operation like updates happening on the SQL Server. Already committed data should not be lost. That's the meaning of ACID properties of transaction, and every single transaction should be ensuring this ACID properties.
Oh, okay. Deepthi, do you want to quickly help us use this example of the bank account? So just to be sure that all of the students listening can understand what you're saying, for the newbies among them, that is. I know usually in a SQL class, there is this example they always use of a bank account if I'm trying to send money from one account to the other.
Right.
To be sure that, yeah, so do you want to quickly walk us through that example just to be sure we're all on the same page?
Of course, yeah.
Yeah.
So let's take a bank transaction, right? A very simple bank transaction. Let's say I have $500 in my account, which have an ID of one, right? Account ID of one. And I would like to gift $100 to my friend's account, which have an ID of two. So this particular simple transaction have two operations in it, right? The first operation is to deduct $100 from my balance, which have $500. Once I deduct, it will make $400. That is the first operation inside that transaction. And the second operation is to credit $100 to my friend's account, right? So I can do this transaction multiple ways, right? I can use mobile phone application or I can even use the online application. For this example, let's say we are using the mobile phone application. So once I begin the transaction, the first operation SQL Server does is it will deduct $100 from my balance, which will make $400. And then it will go to the second operation inside the same transaction to be inserting $100. But let's say something happened suddenly in between, like suddenly the SQL Server went down and I don't even know if I lost $100 or if my friend has received $100. So I immediately called the bank customer service guys. I was so angry at them. They were like saying there was a severe thunderstorm and some of their SQL Server went down and they restarted the SQL Server. So just imagine if this particular transaction is ensuring the ACID property, right? My
Yes.
transaction has stopped in between. It did not complete it. So once they restarted the SQL Server, this particular transaction has completely rolled back, making my data in the consistent state. Now, where is my money? My money is back into my account. My $100 is back, reflecting $500 in my balance. That's how the bank transaction works. If something happens in between, money don't go anywhere, or the transaction will be completely rolled back, or either
Okay.
it will complete successfully.
Okay. Thank you very much. So everything has to complete as a whole or not at all. Okay.
Yes,
Okay. So I also believe when a SQL Server is passed, or when a SQL Server query, is passed to the SQL Server engine, a number of things happen, right? So
right.
can you walk us through the life cycle of a query? But first of all, like I mentioned when we started, I want us to assume zero knowledge now. So maybe you need to first of all explain to us what a query is before the life cycle of a query now.
Right. Um, like example of a query, just to be very simple for you guys, the bank transaction, let's say, right?
Yeah.
Like we are using the mobile phone application. When we go ahead and try to deposit, behind the scenes, SQL Server will run a query like an update statement, right, to deduct $100 from my account. That's a query that is happening. So one operation that we are doing can contain multiple queries behind the scenes, one after the other. But all of those operations can be one transaction, right? Because if something break in between those operations, the transaction should be completely rolled back. So if the life cycle of a query, to be very simple, I'll explain it very simple to easy understanding. The first step that the SQL Server will take is to check on the query, like whatever we are submitting the query, like let's say the select star from a database, right? From the table, right? So SQL Server will first go ahead and parse the query. What does the parse mean? Parse mean to check any syntactical errors of the query. Once it checks the syntactical errors, it will send to the different component, which is known as a binder. So what this binder does is, okay, now the syntax is correct, but whether the tables that we are using are valid or not, like whether the column names that we're using are valid or not, those kind of things are checked at the binder component. Once these both are checked, then the SQL Server will send the query to the next component, which is a simplification component. So sometimes we send complicated queries, right? So SQL Server behind the scenes, it have a chance of making the query simplified. Like let's say you have those subqueries in your query. Those subqueries behind the scenes will be converted into simple joins like left join, right join, outer join, inner join, those kind of simplification component. Once that phase is passed, the query will go to the next phase, which is known as trivial plan. Trivial plan at this component, this is how SQL Server think. If at all we are sending a very simple query, right? Select star from a table. Then SQL Server think this way, this is such an easy query. Why should I even like go ahead and save the create a execution plan and then save that plan inside the plan cache? Like all of our servers has cache in it, right? So whenever this query gets run, there is this query plan gets created for every query. So that first that query plan gets created, the next time you run the same kind of query, same query again, it don't have to pass through all of these components again. It can directly go ahead and use the same query for the execution. So if at all our query is so simple, right? This trivial plan component think, why should I even go ahead and create the trivial plan, save that plan inside the cache? Let me go ahead and just create the plan on the fly like that. But I do not want to save this plan inside the cache because I wanted to save the cache for more complicated queries. This is such an easy query. So let me build a simple plan and then go to the execution phase. But what if our query is so complicated? What if our query has like 10 tables in it with a very complicated logic in it? Then it will be sent to the second stage, right? Now the first stage and the second stage comes under the relational engine. That's a part of the engine inside the SQL Server. So the second stage, If it is complicated, then it will go to the second stage. Inside the second stage, there are several components, like there are three components mainly. The first component inside the second step is load metadata. The name says like it's really complicated metadata kind, but it is very simple. Let me explain. Load metadata meaning behind the scenes, SQL Server has to do some estimates, like even before execution, if it can estimate how many rows does the SQL Server think going to come back. If those kind of things it can estimate easily, it will be easier for the SQL Server to go to the runtime phase to execute the query easily with less amount of resources. So it will go ahead and find those estimates kind of thing, and then gather all that information, and it will build a parse tree, like the which I said, like the query tree. It will build, and now as is a complicated query, it will be saving that plan inside the cache. Once these kind of estimates are built, then inside the second step of this phase, it will go to the second step. So what is the second step? Load metadata join heuristics, right? So join heuristics is also very simple. Like let's say we are running a very simple join statements in between three tables, right? So maybe the join between A to B is filtering out around 60% of the records, right? And the join between B to C is filtering out around 99% of the records from the result set. In that case, SQL Server think, why should I even go from A to B and then B to C? Because B to C table is filtering out 99%, right? So let me go ahead and reorder the join in between these three tables such that I can get the results as quickly as possible. So it will do those logistics, join heuristics, and it will go ahead and update that information in the query tree that we are building inside the cache, right? So once it built that, it will go to the third step inside the relational engine, right? The last step of this second step. The last step here is, let me see, I have written it somewhere here.
Okay.
So load metadata, join heuristic, search phases. So there are like three kinds of search phases. This is a little bit deeper, but let me say, like, no matter what kind of query we will be sending to the SQL Server, all the queries has to get that query information from these three phases, depending upon how complicated your query is. So once it gather that information, that query will go to the third step, like storage engine component. So the storage engine component, what happens here is the data should be gathered from the disk subsystem, right? So for the select statement, it will just go ahead and grab that information from the database files inside the disk subsystem in the form of 8 KB data pages. It will do the select inside the memory. No matter if the insert or update or select statement, we directly do not update or insert data directly inside the disk subsystem database pages. We have to grab those pages inside the memory, do the operation over there, and give the results to the user. So for the select, the pages will be grabbed inside the memory, do the select, and send the results. For the update or insert, the pages will be grabbed from the disk subsystem, do the modification inside the memory, and then send the success message to the user. That's how the life cycle of a query works in an overview.
Okay. Thank you very much for that, Deepthi. But we need to go on a short break now, and we'll be back in a little bit. I have my producer also here with me. I'm sure she's wondering, all this Google the Gook is looking to her. I'm sure she probably would have some questions for you after the break. So we'll be back in just a little bit. So we're back. It's still the Tech Talk Wednesday with me, Kazeem, and I've got Deepthi again on the show with me this afternoon, and we're talking SQL Server. And she just ran us through the life cycle of a query. You passed a query to a SQL Server. The cycle is what we just went through just now. It would be nice, I'm sure, to see all of this in a demo. But it's looking like the time will not be would not be able to do that today on the show. So maybe we can rearrange. We can arrange to do this some other time, right? The demo part of things. But quickly, Deepthi, it would be nice to also understand performance, right? When we talk queries, it would be nice to be sure that our queries is fine-tuned in such a way that we're getting better performance optimization, from those queries that we're issuing. And I know we have a number of techniques, or do I call them concepts now, that is tied around performance. You've mentioned some of them earlier. You mentioned trivial plan. I know there's also, pre-optimization stages. So do you want to just quickly, in just a little bit, say in about a minute or two, walk us through what those are?
So you mean the optimization, right?
Yes.
So whenever a query is running, like let's say the stored procedures, it doesn't have to build the query tree like we discussed earlier each time it runs. Once it builds a good enough execution plan for that query, it will go and save that plan inside the plan cache. But the thing is, we have to make sure that good enough plan is stored inside the plan cache, right? Sometimes, let's say, to be very simple, like whenever you are executing a store procedure with a single variable, you are getting like 1,000 records. But with the same store procedure, if you are executing with a different variable, it is giving us like 1 million records, right? In that case, we have to make sure that the query plan that is being generated for the query will be optimal, right? Because now we are having these issues, like for one variable, we are getting some rows, and for the different variable, we are getting many rows. So in that case, we have to make sure the query plan that is being saved is optimal. Now, how do we know that the optimal plan gets saved? Is based upon statistics. Like I said, like SQL Server have to estimate, right, how many rows it think going to come back. So these are every table have statistics on it. Statistics is nothing but SQL Server. It stores some information inside the system tables to describe the distribution of the data inside a column or set of columns or an indexed view. So basically, these stats are generated automatically, but we have to make sure we are maintaining these statistics by using the maintenance plans. So once we maintain them, it will be mostly probable that our plans that are generated will be optimal as well.
Thank you very much for that. So in trying to wrap up now, Deepthi, you're a DBA, you're a database administrator. So if we have people listening to you right now, especially the students now, and they're looking to embrace database administration as a career, what does a daily routine of a database developer or a database administrator like yourself looks like?
So the first thing is database administration is a wonderful job. Like if you are bored of doing the same job every day, then this is the job for you because DBA job is we all learn new things every single day, right? So what are our responsibilities as a DBA? As a DBA, we configure SQL Server databases, we configure SQL servers, we do maintain SQL servers by running the maintenance plans, and we have to make sure all the databases are 24/7 available, right? Because all of these websites are handling these database behind the scenes. And also we have to make sure we are upgrading these databases to the latest versions of SQL Server. Just like the iPhone, every single year we have releases. For the SQL Server as well, we get new features. So we don't want to stay like old school, right? We wanted to upgrade. So DBAs will be responsible for these migrations. And the newer thing that is coming up is Azure, right? Azure. So everything is in the cloud. So it is like your job responsibilities are absolutely awesome because everybody in the company, even the CEO, will be respecting you and they have to listen to what you say. because even if they need permissions onto the database, they have to come to you and request the permissions, and it's your call to give or not give the permissions, because you are the one, you are the king of all the databases, right? So I'm telling all of this because I'm a DBA. I love my job, and I just wanted to put some things together here because this is a wonderful platform where I can because I love sharing my skills and sharing my knowledge with other people. Like you have students, right, in your university. If anybody want any information or because I teach SQL Server all the time for free. So if anybody want any help, just keep in mind that Deepthi is available here. My Twitter ID is @DBANuggets. If you wanted to know any information, I am readily available to help you all the time.
Okay. Thank you so much, Deepthi, for coming and sharing your knowledge on the show with us this afternoon. So I'm afraid this is where we're going to call it a stop on today's episode of the show. We can have a rewatch of this on YouTube. So it's the Tech Talk Wednesday across the social media channels. So any last words from you, Deepthi, before we say goodbye?
I wish good luck for each and every student, and I'm so thankful to be on this stage. Kazeem, thank you so much for giving me the opportunity. And whenever possible, like any events, like online events happening, if you can let me know, I will be willing to provide sessions for you. And good luck to all of the students out there.
Okay, thank you very much, Deepthi. All right then. So let's do this another time. So it's bye-bye from myself, Deepthi, and the rest of the team.
Bye-bye, Kazeem, and all of the students. Bye-bye, professors.
Bye-bye.
Bye. Bye.
Bye.